Hello everyone, today we want to talk about the unit impulse signal, which is one of the most important signals in the signal and system course. The impulse signal in the time domain is represented by delta of t. If we want to draw the signal in the time domain, it looks like this. It has a value of 1 only at the moment when time is equal to 0, and all other times its value is 0. The next point is that the integral of delta t from t1 to t2 is equal to 1 if 0 lies inside the interval, and otherwise it is equal to 0. For example, the integral from 1 to 3 of delta t is 0 because 0 doesn't exist inside the interval of integration. The next point is a property called the shifting property. This property says that any signal multiplied by delta t means that only the value of the signal at time equal to 0 is important for us. We can write this result as delta t times value of the signal at 0. There is an integral that is very useful, and we use this property to evaluate it. The integral of delta t multiplied by xt can be written as the value of the signal at 0 multiplied by delta of t. Then we can take the value of the signal at 0 outside the integral. Another point that many students get wrong is when delta t is shifted. For example, delta of t minus 3 no longer has a value only at time equal to 0. This time the signal has a value of 1 at time equal to 3 seconds, and it is 0 at all other times. So, for example, when you write a signal of t multiplied by delta of t minus 3, the result is no longer the value of the signal at 0 multiplied by delta t. Instead, it is the value of the signal at time equal to 3 multiplied by delta of t minus 3. Another property that is very important is convolution. The convolution of any signal with the unit impulse result in the same signal. Similarly, the convolution of any signal with a shifted unit impulse result in the same signal but shifted by the same amount. The next point is the Fourier transform of the impulse signal, which is equal to 1. This means that in the frequency domain, the transform is equal to 1. If you pay attention, the impulse signal has a value only at a single instant in the time domain, but in the frequency domain, it has a value at all frequencies. Another point that we should mention is that many students think the impulse exists only in the time domain. No, we also have an impulse in the frequency domain, and we represented it by delta omega. In the frequency domain, its value is 1 at frequency equal to 0, and its value is 0 at all other frequencies. Now, which signal has this Fourier transform? It is 1 divided by 2p. However, this is usually expressed in a better way by saying that the Fourier transform of the constant signal equal to 1 in the time domain is equal to 2p times delta omega. Another important point is that if you have an LTI system and you apply a unit impulse to this system as the input, the output is represented by HT. This output is called the impulse response, and this impulse response is very important in analyzing and studying LTI systems. Another point is that if you take the derivative of the unit step signals, the result will be the impulse signal. If we want to draw the unit step signal, it is equal to 1 for positive times and equal to 0 for negative times. If you take the derivative of this signal, in the regions where the signal is constant, the derivative becomes 0. And at the point where there is a jump, the derivative appears in the form of an impulse. If you find this teaching style interesting, you can follow more videos on our channel.